All right, good morning. Today's warm-up reads, if you react 50.0 milliliters of a 3.5 molar solution of ammonium sulfate with 65.85 grams of barium nitrate, how many grams of precipitate will form? And so the very first thing that we have to do here is write our balanced chemical equation. Which is as follows. All right, you may be asking, how do we know if this right here is aqueous or solid? In this case, it doesn't matter. It could be aqueous, it could be solid. At the end, we're going to end up with a beaker with an aqueous solution and a precipitate forming. And since it's not necessarily specified, it is just giving you grams, we could just assume that it's a solid. So now that we have our balanced chemical equation, we can then start to look at how we're going to solve this problem. It says how many grams of precipitate will form? Well, we are given a very exact amount of two reactants. In this case, we have ammonium sulfate and we have barium nitrate. So those are my two reactants that I have here and here. So I cannot proceed until I first find my limiting reactant. Now I know I want to know how many grams of precipitate I'm going to solve. I need to find, so I'm going to go ahead and use that as my technique, so I can go ahead and kill two birds with one stone, if you will. Not that, of course, I advocate killing birds. Please don't kill birds. It's just metaphorically speaking. Anyway, I digress. The point is, I'm going to start with what I have. So the first easiest thing I have to do is I have 65.85 grams of barium nitrate. Since that's already in grams, it's going to make it very easy to convert to moles. Because then I just need my molar mass here. So 261.35 grams in 1 mole. Now that I have converted to moles, I can then use my molar ratio between my barium nitrate and my precipitate, in this case, the one that produces the solid, which is barium sulfate. This is a 1-to-1 ratio. So 1 mole of barium nitrate is equal to 1 mole of barium sulfate. Now that I have moles of barium sulfate, I can go ahead and convert that to grams using molar mass. There's 233.4 grams of barium sulfate in 1 mole of barium sulfate. So when I work all of this out, considering sig figs, I end up with 58.81 grams of barium sulfate. And like I always say, it's not good to just plug and chug. We got to think about what we're doing and why we're doing it. So what did I just do? What I've done is I have figured out how many grams of precipitate, in this case my barium sulfate, I can form if I use all of my barium nitrate. So in other words, if I react 65.85 grams of barium nitrate, all of it, based on this reaction, I should make 58.81 grams of barium sulfate. Why did I do that? Because I'm trying to find my limiting reactant. So I need to compare to see which one's going to produce the least amount. All right, the next one's going to be a little trickier. And the reason for that is because I am starting with a volume of a known concentrated solution of ammonium sulfate. In this case, 50 milliliters of a 3.5 molar solution of ammonium sulfate. So first step is convert to moles. That's the first thing I need to do in order to do stoichiometry. So I'm going to use molarity is equal to moles over liters. Let me just go ahead and put that aside here. All right, so in this case, I know 3.5 is my molarity. I want to know moles, and I have liters. Remember, never forget to convert to liters. And so here I'm going to get N is equal to 0.175 moles of NH4 2SO4. All right, remember we're not rounding till the end. If I just wanted to know how many moles, then that would be with sig figs 0.18. But since I am working all the way through to find my limiting reactant, I'm going to keep it as is. Now I have a starting point. Okay. Now I can just use my mole ratios. Now again, I'm going to pick my ratios between my other reactant, in this case ammonium sulfate, and barium sulfate, because I'm going to compare it to my previous calculation. All right, we got to keep it consistent. So now that I'm moles in barium sulfate, I can now use my molar mass. 1 mole barium sulfate is going to be 233.4 grams. Barium sulfate. So this should mean that I get 40.8 grams of barium sulfate. All right, so now let's see what do we do? Why do we do it? We found out that if I reacted my 50 milliliters of a 3.5 molar solution of ammonium sulfate, this is how many grams of barium sulfate I would make. Okay. Why did I do this? I did this because I want to find my limiting reactant. So my limiting reactant here is going to be whichever one produces the least amount. Why? Because once I'm out of this reactant, that reaction is going to stop. So which one produced the least amount? It's going to be my ammonium sulfate. So in this case, I know that my limiting reactant is my ammonium sulfate. Now to answer the question, how many grams of precipitate will I form? Well, I've already calculated that. I'm going to form 40.8 grams of barium sulfate. All right, my second question says, what is the percent yield if the reaction above is performed in a lab and 38.85 grams of precipitate is formed? So my percent yield is equal to my actual yield, this is what I'm actually producing in the lab, over my theoretical and my theoretical yield is what I calculated using stoichiometry. Multiply this by 100 and that again gives me my percent yield. So in this case, let's identify theoretical and actual. So here the question that says, what is my percent yield if the reaction above is performed in a lab and 38.85 grams of precipitate is formed? So this is what I actually formed. This is what I got when I did the lab. So that's going to be my actual yield. Okay. My theoretical yield I figured out in the previous problem. And I figured that based on my limiting reactant, I was going to make 40.8 grams. Okay. So that again was based on stoichiometry. So this is again actual 38.85, theoretical is 40.8. So I can just plug it into my formula of 38.85 grams over 40.8 grams. Multiply this by 100. And my answer should end up being 95.2%. Okay, so that is my answer for number 2. All right, guys, hope you found this helpful. If you have any questions, again, you can always contact me via Canvas. Shoot me a message. Again, I'm on the conference function from 11 to 11:30 every day, Monday through Friday, so we can discuss. I can actually talk to you. We can have a conversation about chemistry. Don't forget we have a chance to see on Thursday. Hope you guys have a great day. Remember to make good choices.